Hello, ladies and gentlemen, Ender here, back again with another video. Uh, well, this is gonna be a very different video from the ones I usually do about video games and all of that. Of course, because I'm gonna be explaining a chemical reaction. Why? Because I love chemistry and I want to be a chemical engineer. So this reaction is very simple, not too complex, so let's dig into it. So if you've ever gotten wounded, you've probably been applied this. What's this? It's oxygenated water, otherwise known as hydrogen peroxide. Now, this compound is quite unstable. Let me tell you why. So, normally, we would present water like this. Simple, right? Oxygen is bonded to hydrogen atoms, completing its octet. But we are forcing an oxygen molecule, atom I mean, into this, which is already structured. So we get this, and it's unstable because this is not natural. We are forcing it. I know I'm repeating myself too much, but emphasis, I guess. Nah, I'm repeating myself too much. Anyway, so what will happen eventually is that this will decompose into water and oxygen. That's more natural, but this should be like this, but I'll explain it later. That's a 2. I didn't do it right. That's a 2. I'll explain later why 2 and not simply 1 oxygen. Alright, so this process of decomposition takes a very long time. Or maybe not so much, but what happens is it takes time and we would like it fast. And this is where catalysts come into the scene. So you can have this plus potassium iodine. Now, what potassium iodine will do is decompose the oxygen. How? Why? Well, potassium iodine in this reaction acts as a catalyst. What a catalyst does is basically making processes for reactions faster. In this case, with potassium iodine in the mix, it takes less energy and less time to decompose the oxygen from hydrogen peroxide. Eventually, this will get us to this result, which is water, normal simple water, plus potassium iodine, plus oxygen. Alright? Now, I told you earlier that this actually should be 2. But I'll tell you why. Right now. What happens is diatomic oxygen is more stable. Diatomic oxygen is more stable than simple monoxide. Than a simple atom of oxygen, I mean. This is gonna be a very raw and very bad video. Anyway, so this is actually not a very well balanced equation. The correct equation would be like this. So we have 2 plus 2, 2 times 2, 4. We have 2 times 2, 4 hydrogen atoms. We have 2 times 2 oxygen atoms, which is 4. Forgot to mention it's 4 in all cases. And here we have 2 times 1, 2, and 2 again. So diatomic oxygen is more stable than a simple atom of oxygen. It can happen, but it usually doesn't. And in this reaction, it does not happen. So that's it. I guess it's not that hard.